All right, so in this session we're going to look at some basic Rhino tools, and I'll be covering kind of the general working environment, some of the fundamentals, and we will start developing some geometries like curves, surfaces, but primarily our focus is going to be on developing surfaces. So this is our working environment with the construction plane, and the way we navigate around the working environment is by using the right mouse button. So the right mouse button triggers orbiting, and then if you hold shift on your keyboard and do the right mouse button, that'll be panning, and then you can use the roller to zoom in and zoom out. And that's essentially how we navigate in the environment. And if you want to, let's say, grab geometry, there's this selection tool here, but you can also grab individual elements like surfaces, curves, and you can also use marquees. Basically, you can drag a marquee from left to right, which will give us a solid marquee, and it will grab everything inside of it. But there's another type of marquee, which is the dashed marquee, and that's drawn from right to left. And that basically grabs everything that it not only encompasses, but it also intersects, right? So if I, for instance, want to grab something here like that, it basically grabs all the intersecting geometry. But if I want to grab this point here, I can use just a solid marquee, and I'll be grabbing that point, or like this line segment, for instance. Okay, we have basically our layers tab here. If for some reason this is closed, let's say I don't see these tabs, you can go to edit layers and edit layers. This will prompt this menu, and then you can also grab and drag it anywhere on your working space and place it there. So we're going to work with some layers, and I'm going to start by defining some layers, basically. So I had some examples here already plotted, and we'll be covering some of this, but you can also start replicating some of the stuff that I'm doing to learn about how to organize your material as much as how to draft it properly. So if you want to create a layer, you can come here, do new layer, and give it a new name, let's say point grid 2, and we can assign a different color to it to differentiate it from the rest. So let's say we want to make it green. I hit apply, and then to activate this, I need to double click it. So if you see this check button, that will be the current layer I'm drafting things in. So I can basically plot some points that will be assigned directly on this layer, and we can change the ordering of the layers. We can put them under other layers, and we also have these light bulbs and lock signs, which is basically the visibility option. So if I, for instance, want to hide all the points, I can just turn the lights off here, and all the points or everything in this layer will be hidden. And for these exercises, what I would recommend is to develop points as grids or other types of like placement information, and then you can keep them locked so that you won't have to change them necessarily, and you can use them as guides, basically. Okay, so let's look at some curve tools. So I'm going to switch to the top view. So if you double click here to this viewport, you can switch between views, and this is my top view right now. So I'm just going to zoom into my grid and start drawing some curves. So the curves will be located here, so we can start with polylines. I'm going to switch to the curve layer, and I'm going to snap the grid points and draw a polyline. Now, once we grab onto this, it automatically shows us the control points. These basically control how this information is translated to the curve. But there are also other things we can do. For instance, if let's say we want to change the shape of this geometry, we can use operations like chamfer or fillet. So the chamfer would actually, you would enter two distances. I have 3 and 4 here, so that will give this sort of almost like it basically calculates those distances and trims, connects this new, makes this new line and trims the old curve. So that's basically separated. And you can also join this. Now we have basically added more points onto the curve as well. So one other thing we can do with curves is, let's say you have another curve and we want to, let's say, change the degree of the curve. Now, what do we mean by degree? So right now we are going from point to point. You can see I have 4 points, and this is what we call as linear interpolation. So I'm going from point to point in a straight line. If you want to go from this information in a different way, let's say we rebuild this curve and I increase the degree to 2nd degree, but I want to keep the point count. So I'm using rebuild function here. You can see that the curve is slightly changed. It's because now it's kind of translating every 3 points into an arc, right? So I get this sort of depiction, and you can see like this point is on the curve itself, but now we get 2 arches, right? So these are basically 2nd degree curves, so they define circles actually. So we translated these 2 arches. I'm going to do the same thing for the 3rd degree, which will turn this into a NURBS curve. So if I do rebuild again and use degree 3, now you can see that these points are further extended from the curve, and they kind of control, they're not on the curve itself, but they control the curvature of the curve, right? So I can actually move these points around. What we can also do is, if you go to here, the point edit options, and click on this cascade option so that you can have more options. Here we have basically the possibility of inserting points, deleting points, as well as controlling the weight of these points. For instance, if I choose this point, click on this point weight. Right now the weight is 1, but if I increase it, it will start pulling the curve more to itself, right? So we are increasing kind of its strength in how to influence the curvature of this shape. So we can also work with these sorts of manipulations to adjust the curvature so that this maintains some sort of fluidity, but we can control this shape. One other thing we can do is add control points or insert control point. And this can work with a bunch of stuff. So you can see here when I do it on a NURBS curve, it's basically parametrically calculates how this information can be transversed on the curve, right? So I'm going from these control vertices along the dashed lines, but I'm choosing a point on the curve. So the midpoint is not necessarily the center of it. So it's basically parametrically calculated. So if we include more points, you can see that these weights are kind of pulling the curve too much to themselves. So you can actually start increasing the information a bit more, or maybe delete some of the control vertices, and then kind of control the topology a bit better, right? So if I want to have more curvature like this, like an S shape, I can add these points, and I can also move them around to control the geometry of the curve. And you can do this for any type of curve. So you can do it on a polyline, on arcs, but arcs would cause discontinuities because they're separately drawn. So if I, for instance, explode this, you would see I get 2 arcs, and these are basically like subsets of circles. Okay, so that's those are essentially curves, and I want to show one more thing, which is the handle curve. Most of the time I use handle curve to draw curves, and they're also we should also cover these two, the control point curve and the interpolate points. Let's first look at handle curve. The way handle curve works is you basically assign a point and a tangent. So if I choose this point and then hold my mouse and then drag this kind of tangent curve, you can see that it's kind of positioning this sort of plane on which the curve would bounce. And then you can also add, keep doing this information. Then you will be basically plotting the points from which you want the curve to pass, but also the curvature using these tangents. So I can direct these in any direction I want. And most of the time this helps us maintain some sort of tangency between multiple curves. So it's not intuitive or not easy to make tangential curves, but handle curve actually helps us to achieve that. And once you select them, you can see that these points have been plotted to maintain these sorts of tangent conditions with the handles. And you can also do this in 3D. So if I move here, and if I want to zoom to this, you can do zoom selected. ZS is a shortcut. Or you can go, let's say you want to grab to any of this geometry, you want to focus here. You can go to, let's see, I think it was here, but I normally use the shortcut, which is ZS, zoom selected, and you can zoom here to this geometry, or if you want to work here, you can zoom here. And then once you select these points, let's say we want to maintain this tangency here, but I want this to, let's say, move up. I can choose these points. And what I'm doing here is moving those points in the vertical displacement. So you can do this by turning the gumball on here. The gumball is basically this sort of scalar, rotational, and translational modifier. So you can just move it up and down, and you can modify the information there, so we can embed some more three-dimensional condition to our curves. Okay, so those are essentially some of the basics. Let's look at one more thing, which is the difference between the control point curve and the interpolate points. So I'm going to switch to top view again. So if you do control point curve, you're basically drawing something, the curve, without placing points directly on it. So these will be control vertices. So if I stop this, you would see that these points have been registered as NURBS control vertices, and the curve kind of bounces around them. But if you do interpolate points, this would actually register points directly on the curve itself. But then you can also see these control vertices, and we can modify either one of them. So you can control the curvature through these vertices as well. Or if you go here and turn the points on and choose the curve, you will be able to directly control the topology by moving a point on the curve itself. Right, so there are two different ways of plotting curves, but they can essentially interchange. So I can also find these points on this curve as well and manipulate them here too. Normally when you're tracing images, you use interpolate points. But when you're doing, let's say, freeform modeling, you do control point curves. All right, so that's essentially covering the curves. Now let's look at C-planes. So the C-planes are essentially construction planes that we use to model our geometry in Rhino. And they're located here in this tab, C-planes. And essentially our world construction plane is also a C-plane, right? So this is the plane that we draw the geometry. So the way this works is like if you want to draft anything inside the 3D modeling environment, every time you register a point, your mouse click will be intersected with the active construction plane, and that's how you get these sorts of inputs and get this geometry registered on the construction plane. But construction planes are actually more than that. So let's look at some profiling, for instance. So we have a bunch of ways of describing C-planes. So if you go here, there's one option, for instance, to set a C-plane perpendicular to curve. So I can place a C-plane that aligns with the normal or the or if I want to, let's say, grab a point along this curve, it will be perpendicular. The C-plane will be perpendicular to the curve. So if you choose here, you can see as I'm flowing along the geometry, I actually get this sort of rotation for the C-plane. So let's say I want to grab the endpoint, and now my construction system has shifted to this point. So I'm getting basically the tangent information from the curve, which is this line here, and that becomes the Z direction of my construction plane. And now I can draw anything, any type of profile here. So let's say we want to draw a shape like this, and then I want to continue with this operation. So let's move on to another direction. Let's move to the end of it, and I want to draw another shape here. And we want to combine these as a shape. Let's say we want to do a sweep. So I can choose this rail. These are my profiles. And that will give me a shape like that. Right, so it's just basically the idea is that you can grab any type of point along the curve, and it will give you the perpendicular construction plane on that curve. Now there's another way of assigning C-planes. So I'm first going to exit this mode. So to do that, you need to go back to your C-plane world top, which will be our default construction plane. And then you can actually assign any C-plane using 3 points. So let's say we have, I'm going to switch to point grid, and I'm going to give 2 new points and start moving them in Z. So this is like any 3 points will define a plane, but we don't know where that plane is yet. So I'm going to go here, set C-plane by 3 points, first point, second point, and third point. And the ordering kind of influences the directions of your X and Y vectors. So the red is your X vector, and the Y is your Y vector. So let's say if I want to place a new point and I say 5, 3, 0, that will be placed on this construction plane now. So you can see the X coordinate of this point is 5 units along the red direction, and it's 3 units along the green direction. So that will be a point directly placed on the construction plane. But this goes along with any type of input you want to do. So now I'm basically aligning geometries or profiles in the third dimension on this construction plane, and I can plot a lot of things here. That'll be aligning to that construction plane. So if I go back to my world view, you can see that they're actually placed on that construction plane. Okay, so I want to show one more thing, which is to extract C-planes on surfaces. So for this, I'm going to use a sphere. So let's place a sphere here. And then I'm going to go here to set C-plane to surface. And what this does is it essentially gets a point on the surface and uses the surface normal to basically place a construction plane. So let's say I want to draw something here. Let's say I have a plane like this, and I want to do it a planar surface. And then I want to intersect it with some other direction. And let's go here, planar surface. So now I'm looking at these two surfaces that do not intersect, but they can define an edge, right? So I'm going to switch their layer here, choose them, go to object properties, and place them in the surface layer. And to increase this intersection, what I can do is extend surface. So that will grab any type of edge condition of the surface and extend it. And what I want to do is extract this edge. So you can do that by intersect, and that's the edge. And I can basically use this, scale it, and use this as a trimmer. So I can trim these two surfaces. And now I've created this sort of edge in third dimension by using two C-planes that are tangential to this surface, right? So I'm basically defining an edge. So this is kind of a good exercise to understand C-planes and how to orient yourself, how to transform them, as well as how to plot geometry and intersect them. All right, so we're going to look at some other surface tools like Loft, Sweep, Extrude. And lofting is basically requires multiple curves that you connect. So I'm going to first, for this exercise, I'm going to do a point grid. So you can do it here under the point option. You just open up the cascade and come down here. There's a point grid option. And you can enter the number of points you want in the grid and kind of a dimension. So let's say I want to keep it more horizontal and this direction vertical. And that places these points. If you want these to be larger, you can go to display options and go to points. There's a point grid size and style. If you increase the sizes here, you can see them a lot more clearly. And I'm just going to lock them here. So for lofting, we need essentially some curves, and they could be polylines or NURBS curves, basically. So let's go to here. So I'm going to snap to this point, and my object snap options are open. They may not be in your case. So if any of these are not ticked or this whole bar is disabled, you won't be able to grab these points. You won't be able to snap to anything actually. And this kind of helps us to snap geometry to the right place. For instance, sometimes you want to, let's say, find the intersection point or use the intersection point or get the end point. So you can just turn off everything else, but just keep the end point and you'll be able to snap to that, or you just turn on points. For instance, now I'll be only snapping to these points. So that's kind of a way of controlling how to snap to geometry. And I'm basically going to draw a bunch of profiles here. Just arbitrary profiles, nothing fancy. And we can start lofting. So for lofting, you want to basically grab the same edge of the curve for it to be connected well. So that's how this information is connected. You can see it's drawing these curves essentially between these points as well. So it's interpolating the information. And right now we have the style as normal, but we can also do straight sections, which will make this into polylines, right? So they will be linearly connected, but then you will get these sorts of twisting surfaces. So let's get our surfaces. You can see these are kind of twisting shapes. We can also try to do, let's see, let me show you. If you do loft, and let's say you want to loft the other direction, like by accident you clicked to this top portion, and then you click bottom here, top and bottom. Rhino essentially registers how you want to connect and takes it as the way you want to connect these shapes. But then if this is not right, you can do align curves and flip this information by clicking onto these points. So that will give you the right type of loft. Okay, so let's do another one with, I'm going to move this to surface. I'm going to make a copy of this. So it would be nice to loft or organize all this information using grids, because otherwise we don't have any orientation for these surfaces. So one thing we can do here is to do rebuild. So I can do a rebuild curves. So let's say we want to turn them into third-degree curves. And some of this information kind of passes over the grid. So what you can do is push this back to the point grid, or like push it up to control it if you want. So this point will be remaining on this construction plane, or you can also come in and again use the handle curve to plot new curves here. So I can go from here to here, something like this, and I'm going to keep them as is. So we can do loft. I'm choosing these sections, but I'm going to do normal, which will give me kind of a smoother shape. So that's like a lofted surface that I have. Okay, so that's essentially it. And I want to show one more example of how you can use lofts. So let's say you want to model something like this, like a corrugated surface. You should also think about modeling this as a grid. Let's move to our viewport here. And what I'm going to do is draw those curves. We can do it horizontally or vertically, it's totally up to you. But let's say we draft these curves here, something like this. And I want to just multiply this information, so let's make a new one, make a copy, and then I'm going to rotate this vertex so that this edge length will be the same. I'm going to explode, delete these, and then mirror it. And then we can copy or array it. So let's say this information is going to translate to this. So I'm using zoom selected. If you have too much clutter, like I have in my modeling environment, and you want to just isolate stuff, you can always use this function here called isolate objects. And that's basically will temporarily hide everything else so that you can focus on the geometry you have at hand. And I'm going to just make copies here. So if you do loft, let's see, this needs to be joined. So now this is kind of a normal, but what I want to do is straight sections. It's like folded paper. You can see I can actually model these sorts of surfaces by controlling the section profiles of the folds themselves, right? So this can be further extended in any type of shapes we want. All right, so let's put that aside as well. So I'm going to look at sweeps next. And sweeps are essentially, I modeled one here, but let's do another one so that we can see how that works. So I go to sweep. Let's see, let's make another grid here. And I'm first going to draw a curve in three-dimensional curve. So if I go to handle curve here, I'm going to grab some of these points and hold shift, and then make this type of make this type of snake-like figure. So I have something like this. And for sweep, we essentially need profiles as well. So if I have a singular profile, let's say my profile is just a U shape like this, I can do sweep 1, choose this curve, choose my profile, and that'll be extruded along it. Now I'm getting some error here, and that might have to do with the size of this shape. Let's actually show that again. The size of the shape and the curvature of the path. You can see it's kind of self-intersecting here, and that's kind of not looking good. So what we need to do is like either make this smaller or change the path, basically. Let's see, this is still giving an issue, so probably this turn here is too sharp. So what we can do is move some of these points around so that we can relax it a bit. Let's see if this would work. Yeah, it's still kind of giving an issue. Maybe we can do like rebuild, have 6 points. So I'm kind of deviating from those points initially, but I want to smooth my path. And that's basically, this shape is aligned to those points along the curve, and it will be swept along it this way. All right, let's look at this type of sweep, which is basically using sweep 2 command. So sweep 1 just has one rail and profiles. This can actually also have multiple profiles. So let's say you want to place another profile in between and at the end. You can use the C-plane, go to perpendicular to curve, and I can actually make this shape a bit different so that we look at how it changes or reacts to it. Then I'm going to go here and let's see, something like this. So if I do a sweep 2, 3, so I choose those 3 geometries in an order, and I basically get a shape like this, right? So I can control the section of the sweep along the curve path. So this was uniform. This had the same profile, so I only use one profile. For this one I had 3, and you can see that information is being connected. And most of the time you want to keep the number of vertices along the profiles the same, because if I have, let's say, 4 or 5 control vertices here, then this information will need to blend with it. So let's look into that. For instance, let's delete one control vertex here, and then let's see how that information is affecting our sweep. So if you look carefully, you can see that these 2 edges are merging along this edge, right? So that's essentially a different number of vertex for this profile. That's why you get this sort of connection. All right, so I want to show also sweep 2. So sweep 2 essentially works with 2 rails, right? So that's kind of the difference. So I'm going to grab my point grid and draw 2 new rails. Let's draw another handle curve here. So I'm going to start here and then end here. And for the top, I want to start here and end here. And in between these, I want to draw some profiles. So let's say we want to go from here down there like this. And from here, I want to go like that. Let's actually move this down a bit. So let's see what this is going to make. So I'm going to do sweep 2 this time. If you do sweep 1, let's actually look at the difference. If I do sweep 1 and choose one rail, you can see that it doesn't follow necessarily the top curve. It quasi does it, but it's not exactly on it. So the sweep 2 option makes it kind of fixated on these end rails as well. So we are kind of defining the boundary of the surface. So it gave me something like this. So you can see all these edges are kind of twisting and merging onto these other profiles. So Rhino does a good job of finding this correlation between the profiles, and you can get very nice geometry modeling like this. So that's essentially sweep 2. Let's look at extrude. So I'm going to show a bunch of ways of using extrusions. So the default version is, of course, you have, let's say, a profile, and you want to just extrude it in some direction. So let's say you have a profile like this. So let's move top view. So I'm going to draw some zigzags, like folds, for instance. And if you join these, and if you do extrude, I do extrude curve. Let's see, extrude curve. So it immediately recognizes the plane on which the geometry rests, and it calculates the direction I want to extrude. So this is kind of a planar curve, and it can register this type of vertical displacement. But you can also do extrusions in other directions. Let's say I want to, let's say this is kind of a profile in third dimension, something like this at an angle. And I want to draw 2 new lines. Let's say I want to have a direction going this way, and I want a direction going this way. And let's move this down a bit, inward a bit, this one moving up in this way. So let's say that kind of crease is where the fold is happening, and then I want the extrusions kind of follow these directions. So we can do extrude curve. I choose my profile, and you can see it recognizes its normal direction, but I want to extrude in another direction. You can choose direction here, choose base point as this corner, and then choose the second point for the direction. So right now it's pushing it down. You can grab onto this point, but it kind of arbitrarily grabs this extrusion dimension. So what you want to do is also choose base point. And if you choose this corner, then you can directly give it this dimension for extrusion. I can also do it the other direction. So I choose this profile again. Direction is along this curve. And if I do set base point to this corner, I can basically extrude it in that direction. So I get something like this modeled. And we can essentially keep going with this, right? So I can do extrude curve, choose all of these boundaries for direction. I can also manually input directions, but I can also grab it from somewhere else. Let's say I want to grab this edge here, and I want to go up. Okay, so that's essentially like this fold is happening along this corner, but we were able to control how to fold or extrude the rest of the surfaces. Now, one more thing I want to show is extrude curve to point, which will be essential in constructing triangles or plated geometry. So one way you can approach that is, let's say we want to triangulate a surface. So we can again create a point grid like this, but this time I'm going to start with a planar surface. So I grab these corners, and I want to rebuild this surface into third degree in both directions, and choose points and grab, let's say, this corner here and move it up to this position. Grab this point, move it down grab this half, move it up here. So let's say we have some sort of folded condition like this for the surface. So the point grid kind of helps to orient us in terms of surface patches. Otherwise, you might get lost, because this sort of orientation for handling NURBS curves kind of helps to achieve more smoother geometry. Now I'm actually going to switch gears, so I'm going to lock this point grid, or we can also hide it, and move to the curve layer, and I'm just going to plot some points on this on the surface. So there are a bunch of ways you can do it. You can do you can go to point tool. There's essentially extract points command. Let's see, we can extract these points, but they won't be on the curve itself. They're control vertices. There is drape point grid over objects command, which will basically help you tessellate this in a way. So if I go to the top view and give it some spacing, let's say I have 50 right now, and I just drag a window, you can see it basically shoots these points onto the surface, and they will be they will find these intersections on the surface itself, and these can be used for a bunch of different ways. You can also do it at an angle, but let's see, let's increase the spacing a bit. I'm going to do 150. That's not too much, so let's do 100 instead. We need, I guess, more, like 70. I guess 50 was okay. All right, so let's say we have these points. This can also work, by the way, at an angle. So let's say you want to do it in this view, you want to do 150, and drag a window here. That will also add more points. Now I'm switching to wireframe mode, and what I'm going to do is build this out of triangles. So I'm just going to do triangle here. So every 3 point will define a plane, like we talked about. So I can just do it as a planar surface, and then you can use extrude curve to point command. So I do extrude curve to point, and you will be able to grab an edge and extrude it to these points, and you will be essentially reconstructing the surface out of these points. And there should be a way of constructing them. For instance, you shouldn't go from here to, let's say, here, right? You want to distribute them in a way that you grab maybe the closest triangles. So this way you can actually build the surface out of planar elements. So if I hide this, now you can see I have basically a new construction of the surface using these triangles. And I can keep doing this basically. So if I do extrude curved point, I can go from edge to edge and just hitting spacebar and running the same command basically, and trying to find the right edge to construct. Right, so it could be done very fast. Okay, I'm not going to do the rest, but I guess you get the point. So that's like a triangular construction. Let's look at, so this is what we have done. So drape point is the command. So if you go here, the tool is here. So you just do drape point over grid of drape point grid over objects. Basically, you can draw points in a direction you want. Now let's say we have a like a more challenging task of tracing an image, something like this, something that we have maybe done physically. How should we approach doing that? So now that we have learned some of these surface modeling tools, you can think about this as Okay, there could be some sweeps, there could be some planar surfaces, but for some areas, maybe you won't be able to model it in a direction, right? So when I look at this, for instance, there's this this portion that is kind of topologically different than the others. So this part kind of moves in this direction, this part kind of moves in this direction, maybe this one as well. Well, the edges here are kind of a problem. So we need to develop strategies of translating this into a surface model, basically. So what I do is I first go to Curve tool and then open up this tab here, and then since we are tracing an image, we want to interpolate points, right? We want to grab certain points on the curve, on the image itself. And for this, you don't want the grid snap to be on, so you can turn this off, and you can come down here and then start placing some of these points and see if you can extract the curve. And for some points, you might be slightly off, and what you can do is you can come back in and modify your control vertices. But you should be doing this with minimal information. So I wouldn't recommend putting, let's say, 10 points here, because then you'll get a lot of, you will lose the curvature or the smoothness of the curve. So you need to rebuild these into simpler curves, basically. Okay, let's do one more here. And that's essentially it. But what we also need is these boundary conditions. So I'm just going to do those as flat lines. So essentially what I'm developing is a flat surface. Like these conditions are basically, I'm just tracing the geometry as if it's flat. So I'm just going to show you what I mean. If you go here, you can see I've traced the image, but it's just flat right now. So what I want to do is find the kind of depth that we are looking for. Right, so I'm just going to break some of the compound curves into single lines so that we can manipulate them individually. And if you want to do some, let's say, manipulation, for instance, let's say we want to grab this point a bit more, you can either go back to increase the weight, so you can pull that a bit more to itself, or you can simply move it outwards, so you can do a little bit of soft touches like this. All right, so that looks okay. This one, we might be able to move it a bit more. And there are some arches here too, so you can see like this has to be an arch, for instance. Maybe we rebuild some of those curved pieces. So let's say we rebuild these into 3 points and 2nd degree, because we want them to be arches. So now I'm going to move into here, and I actually didn't mention how you can place this image, but it's actually pretty straightforward. You can just grab the image from your desktop and drag it as a picture and place it anywhere you want. So you can hold Shift so that you keep the aspect ratio, and you can place images to trace like this, basically. All right, so I'm going to hide this, come back here, and let's see what we do. So let's isolate this, and I'm going to start moving some of the geometry, but let's isolate the image and the curves, and you can put the image on another layer, like default layer, and lock it so that we won't be able to select it. So all I'm selecting now is these curves, and I'm going to turn on the points so that we can start moving some points up and down. Now, what I mentioned with the marquee, right? So you want to be able to just grab the stuff that you want, not the stuff that you intersect, because then you will be grabbing more stuff. If you want to just manipulate these 3 points, you should just draw a marquee around them and then start moving this point up. Same thing goes here. You can hold shift to add more points to your selection. All right, let's move this up as well. Here, let's move. So I'm thinking these are the creases of the surface. Right, something like this maybe. And this point could be up. Maybe this point is up or down. All right, so something like this. Now, how do we build these surfaces? So first I'm going to basically choose these pieces. This is actually not flat, but this one is flat. So we can simply do planar surface for that one. Same thing here, but this one is not planar. So we cannot choose the boundary and make it planar. It gives me an error saying no faces were made. Curves must be from closed planar loops. So for these, you need to use the command patch. So patch essentially takes the boundary of the shape and then gives you a surface there. And you can basically control the sample point spacing, but it will give you kind of a nice result like this. If you want to control also like a point on the surface in the middle of it, you can also include points here. So let's say we want to create like a bulge. We can do patch again, choose these, and it will also include that point information for the patch. Now this part is a sweep, so I'm going to choose these two. Let's try it again. This to that. What's wrong with this? Oh, we need to do sweep too. Sorry. So first rail, second rail, first curve, second curve. That will give me a nice surface so we can look at the shaded view. I can do the same here, so I can do sweep 2, first, second, first curve, second curve. So I'm connecting this edge. But this part is a bit more difficult, right? So this cannot be a sweep. So we need to do another patch there. So I can just choose these edges, draw the patch, and same thing for this in-between area. So I need to choose all of these boundary edges. You can hold Shift to add multiple selection, or Alt to take them out. And that's essentially it. Let's see. All right, that looks pretty good. So let's see how close we made it. All right, there you go. So we were able to basically learn about a bunch of surface techniques and apply them to kind of a physical model that we made. So I hope this will be helpful for you to start modeling some surfaces, some curves, but also experiment with these techniques so that you can develop some digital replications of physical models, as well as these sorts of digital explorations of different types of surfacing techniques, basically. Okay, so next session we're going to look at more examples, more complex ones, but this will be kind of a introduction to NURBS modeling for Rhino.